Hi, my name is Evgeny Laptev. I'm the systems architect at RCNTEC. Now I'm going to demonstrate how the automatic transfer switching, or ATS, works in our Smart PDU RPCM, which stands for Resilient Power Control Module. When the customer has several power sources and needs to organize uninterrupted power supply for equipment with single power supply unit, automatic transfer switching is required to ensure consumers will switch over to second source in the event of power loss on the main power source. It's extremely important to detect power loss on main input and perform switch over to redundant input quick enough so that consumers continue their operation without turning off, as if nothing has happened. Having recognized the importance of this function, we have implemented ATS functionality in the RPCM. RPCM has two independent inlets. The main one is illuminated now by a green light and the backup inlet by a blue light. To demonstrate how this works live, I'll now turn off the main inlet. As you can see, a switchover to the backup inlet occurred without interruption to power supplied to consumers. Now I'll go back to the initial setup by bringing the power supply back to the main inlet. Once the specified stabilization timeout expires, RPCM will switch the power supply feed to the initially active inlet. We call this failback. The second scenario which I want to show is not losing the main feed completely, but getting its quality characteristics degraded. For this purpose, we'll be using a lap autotransformer to reduce the voltage value on the main inlet below the configurable threshold, the lower level of which is set to 90 volts and the higher to 250 volts. By turning the autotransformer knob, I'm reducing the voltage value of the currently active inlet. As you may see, the ATS snapped into action. A switchover to the second inlet occurred without turning off the power supply of the consumers. We can see the same thing in the RPCM Web Management Console, where the second inlet became active and the first inlet is now in a mode where the qualitative characteristics have exceeded the defined limits. Now I'll turn the knob of the autotransformer, restoring the main input's qualitative characteristics. The qualitative characteristics have been restored, and when the specified stabilization timeout expired, a switch over to the initially active input will occur. I'll demonstrate the same thing for the higher configured limit of 250 volts. Turning the autotransformer knob again as before will reach the point where ATS will kick into action and a switch over to the backup inlet will occur. And again, the consumers remain turned on. The switchover is visible in the RPCM's web interface. Now I'll restore the initial voltage values. The power quality of the initially active inlet has been restored. After some time, we'll again see that the initially active inlet will become the main one. This is how the automatic transfer switching function works in the RPCM. Thank you. But for the most curious, I'll now demonstrate what will happen if we turn off both power supply sources. From the consumer's point of view, there's nothing surprising. They've all lost power. But during a 10-second span, RPCM will save information about that event. And in the future, after RPCM is turned on again, you'll be able to understand what happened at the moment the module was turned off. It also allows for notifying external monitoring systems and administrators if the network is still capable of transmitting data. So now, that's really all. If you like the described RPCM functionality, please share this video with your friends and subscribe to our channel in order to learn about new upcoming functionality of our devices. Thank you.